far beyond Neptune, in the cold, silent darkness at the edge of our solar system, something is moving. It is massive, it is invisible, and it has been there for billions of years. For decades, astronomers have noticed strange patterns in the outer solar system, orbits that should not exist, gravitational pulls coming from nowhere, objects behaving as if guided by an unseen hand. And now, after years of careful observation, NASA has quietly confirmed what many feared. We are not alone in our own solar system. Tonight, as you drift slowly into sleep, we will travel together to the very edge of everything we know, past Pluto, past the Kuiper Belt, into the Francine, forgotten realms where sunlight barely reaches, where a hidden giant has been waiting in the dark. So close your eyes, breathe slowly, and let your mind drift gently into the silence of deep space. The journey begins now. To understand what we are searching for tonight, we must first travel back in time, back to a quieter age, when humanity first began to look beyond the familiar. For most of human history, we believed our solar system ended at Saturn. The ring giant was the farthest planet anyone could see with the naked eye. Beyond Saturn, there was only darkness, the unknown, the void. But then, in the year 1781, an English astronomer named William Herschel pointed his telescope at the night sky, and he saw something that should not have been there. A small, blue-green disk, moving slowly against the stars. At first, Herschel thought it was a comet, but over weeks of observation, he realized the truth. It was a planet, a new planet, hidden in plain sight for the entire history of human civilization. He named it Uranus. The discovery of Uranus changed everything. Suddenly, our solar system was bigger than we had ever imagined. The boundaries of human knowledge had expanded into the darkness. But the story did not end there. As astronomers tracked Uranus across the sky, they noticed something strange. The planet was not moving the way it should. Its orbit was being pulled, gently, persistently, by something else. Something invisible. Something massive. For decades, mathematicians worked to solve the mystery, using only pencil, paper, and the laws of gravity discovered by Isaac Newton. They began to predict where the unseen force must be. In 1846, two astronomers, Urbain Le Verrier in France and John Couch Adams in England, independently calculated the same answer. There must be another planet beyond Uranus, a planet no one had ever seen. On the night of September 23, 1846, at the Berlin Observatory, astronomer Johann Galle pointed his telescope to the exact spot in the sky that Le Verrier had predicted. And there it was, a pale blue point of light, where there should have been only darkness. Neptune. Neptune was the first planet in human history, discovered by mathematics before it was ever seen by human eyes. We had felt its gravity before we could see its light. It was a moment of pure scientific magic. But once again, the story did not end. Because Neptune seemed to wobble. Its orbit, its motion through space, hinted at yet another invisible influence, something pulling on Neptune from even farther out. And so the search continued. In 1930, a young American farm boy named Clyde Tombaugh, working at the Lowell Observatory in Arizona, discovered Pluto, a small, Francine world, drifting silently in the darkness, 5 billion kilometers from the Sun. For 76 years, Pluto was called the ninth planet of our solar system. But Pluto was small, too small to explain the strange motions of Neptune, too small to be the hidden giant that astronomers had been searching for. And then, in 2006, astronomers reclassified Pluto. It became a dwarf planet. Officially, our solar system had only 8 planets again. But the question remained. If Pluto was not the planet pulling on Neptune, then what was? Beyond Pluto, astronomers discovered something strange. A vast region of Francine worlds, thousands of icy bodies, drifting in slow, ancient orbits. They called it the Kuiper Belt. The Kuiper Belt is a ring of debris left over from the birth of our solar system. Francine comets, dwarf planets, chunks of ice and rock, orbiting in the deep cold, where the sun is just another bright star in the sky. Eris, Make, Haumea, Sedna, Poir, These are the names of some of the worlds discovered out there, each one a Francine monument to the early days of our solar system. But as astronomers catalog these distant objects, they noticed something they could not explain. Some of them were moving in ways that should not be possible. Their orbits were tilted, stretched, aligned in patterns that made no sense. Unless something massive, something we had not yet seen, was pulling them, the mystery had returned. And this time, the answer would lead us to one of the greatest unsolved puzzles in modern astronomy. Imagine, for a moment, the edge of our solar system. Beyond Neptune, beyond the orbit of Pluto, there is a vast, dark expanse, so distant, so cold, that the sun itself appears as just another star. Here, temperatures fall below -240 degrees Celsius. The void is almost perfectly still. Sunlight takes hours to reach this region, and once it arrives, it is 1,000 times dimmer than the light we feel on Earth. This is the realm of the trans-Neptunian objects. Francine worlds, ancient, forgotten, drifting in slow, immense orbits that take thousands of years to complete. And it is here, in this silent darkness, that the mystery deepens. In the year 2003, astronomers Mike Brown, Chet Trujillo, and David Rabinowitz discovered something extraordinary. A small, reddish object, orbiting the sun at an unbelievable distance, 3 times farther than Neptune. They named it Sedna. Sedna's orbit is unlike anything else in our solar system. It takes 11,000 years to circle the sun once. Its closest approach is still far beyond the Kuiper belt, and its farthest point is almost 1,000 times the distance between Earth and the Sunday. Sedna should not be there. According to our models of how the solar system formed, no object should have an orbit like Sedna's. The planets we know, Jupiter, Saturn, Uranus, Neptune, could not have placed Sedna in such a strange path. So what did? For years, astronomers searched for an answer, and as they searched, they found more objects like Sedna. 2012 VP113, discovered in 2012, another extreme distant object, tilted, stretched, orbiting in the same strange way. 2015 BP519, 2014 SR349, 2010 gigabytes 174, 2007 TG42. One by one, astronomers found more Francine worlds in the outer darkness, and one by one, they all shared something in common. Their orbits were aligned, not randomly scattered, as you might expect, but pointed in the same direction, like arrows, all aimed at a single, invisible target. The probability of this happening by chance is approximately 0.007%. In other words, almost impossible. Something out there was shaping their paths. Something massive, something hidden. In January of 2016, 2 astronomers at the California Institute of Technology made an announcement that shook the world of planetary science. Their names were Konstantin Batygin and Mike Brown, the same Mike Brown who had discovered Sedna years earlier. They had been studying the strange orbits of these distant objects for years, running computer simulations, testing theories, searching for an explanation, and they had found one. According to their calculations, only one thing could explain the bizarre alignment of these distant worlds. A planet. A massive, undiscovered planet, hidden in the outer solar system. They called it Planet 9. Planet 9, according to Batygin and Brown's calculations, would be roughly 5 to 10 times the mass of Earth, a so-called super-Earth, larger than our world, but smaller than Neptune. Its orbit would carry it incredibly far from the Sunday, between 400 and 800 times the distance between Earth and the Sunday, so far that a single orbit would take between 10,000 and 20,000 years to complete. If Planet 9 exists, it would be the most distant planet in our solar system, a Francine, shadowy world, wrapped in eternal night, receiving almost no warmth from the Sunday. A world that has been waiting in the dark for billions of years, unseen, but the question remained. Why have we never found it? The answer, perhaps, is heartbreakingly simple. Planet 9 is too far away, too dark, too dim. It moves too slowly across the sky to be easily detected by telescopes designed to find faster, brighter objects. If Planet 9 is real, It would reflect almost no sunlight. It would appear as just another faint speck in a sky filled with billions of stars. To find it, we would need to look at the right place, at the right time, with the right instruments. And until recently, we did not have those instruments. But that is changing. In 2025, a new telescope began operations in the mountains of Chile, the Verisi Ribbon Observatory. This telescope is unlike anything humanity has ever built. It has the largest digital camera ever constructed, a 3.2 billion pixel sensor. It can survey the entire visible sky every few nights. It is designed to detect faint, slow-moving objects, exactly the kind of objects that have eluded us for so long. If Planet 9 is out there, the Vera Rubin Observatory will likely find it. And when it does, our understanding of the solar system and of our place within it will change forever. But before we explore the search for Planet 9 in detail, let us pause for a moment. Let us breathe. Let us travel in our minds to the place where Planet 9 might be. Imagine standing on its surface, a frowning, silent world. The sky above you is almost completely black. Stars shine with crystalline clarity, undimmed by atmosphere. The Sunday, if you can find it, is just another point of light, indistinguishable from any other star. There is no warmth here, no movement, no sound, only the slow, steady turning of the planet beneath your feet, as it has turned for billions of years, unseen by any eye. This is the world we are searching for, and it may be closer to discovery than we have ever imagined. To truly understand the mystery of Planet 9, we must understand the science behind its discovery. It is a story of patience, of mathematics, of looking at numbers, and finding patterns where others saw only chaos. When Battigan and Brown first examined the orbits of distant trans-Neptunian objects, they noticed something strange. The objects were clustered, not in space but in the direction of their orbits. The longest axis of each elliptical path pointed in roughly the same direction. Imagine a clock face. Now imagine a down-seen clock hands, all frown-seen at slightly different times, but all pointing roughly toward the number 12. That is what Battigan and Brown saw. It was as if something massive was pulling on these objects, tugging their orbits into alignment, like flowers leaning toward an unseen sun. To test their theory, they ran computer simulations, thousands of them. Each simulation modeled a different version of the outer solar system. Some had no extra planet, others had a planet of various sizes, distances, and orbits, and one configuration matched the data almost perfectly. A planet, 5 to 10 Earth masses, in a tilted, elongated orbit, 400 to 800 astronomical units from the Sunday, inclined about 30 degrees from the plane of the other planets. The simulations predicted not only the alignment of distant objects, but also explained other strange phenomena. Why some objects orbit in a perpendicular direction, why the plane of the planets is tilted slightly compared to the sun's equator, why certain objects have been pushed into wildly chaotic orbits. Everything could be explained by Planet 9. Of course, not everyone agreed. Skeptics pointed out that the sample of distant objects was small. Maybe the alignment was just coincidence. Maybe astronomers had been observing only certain regions of the sky, creating a false pattern. This is called observational bias, and it is a serious concern in astronomy. So Battigan and Brown went back to work. They studied the surveys that had been conducted, mapped the regions of the sky that had been examined most carefully, adjusted their statistics to account for biases. And the result? The pattern remained. The probability that the alignment of these distant objects is random has been calculated by various teams to be between 0.1% and 0.001%. In other words, almost impossible. Something is out there. The only question is, what? In the years since 2016, the evidence for Planet 9 has only grown. In 2021, a study analyzed the orbits of all known extreme trans-Neptunian objects, ones with orbits beyond 250 astronomical units. The alignment was even stronger than originally suggested. In 2022, astronomers identified additional candidate objects whose orbits matched the predictions of the Planet 9 theory. In 2024 and into 2025, new statistical analysis by Badigan, Brown, and their collaborators reinforced the hypothesis. The math, they argued, was undeniable. Either Planet 9 exists, or our understanding of the outer solar system is fundamentally wrong. But if Planet 9 is real, where did it come from? This is one of the most fascinating questions in modern astronomy. There are several theories. The first is that Planet 9 formed in the inner solar system, perhaps closer to Jupiter or Saturn, and in the chaos of the early solar system, gravitational interactions with the gas giants flung it outward into a distant, lonely orbit. This is similar to what happened with many comets. They formed close to the Sun and were ejected to the far reaches of the solar system by gravitational scattering. In this scenario, Planet 9 is a refugee, a wanderer, cast out of the warm inner regions and sentenced to billions of years of cold isolation. The second theory is even stranger. What if Planet 9 did not form in our solar system at all? What if it was captured? In the early days of the solar system, our sun was part of a stellar nursery, a cluster of newborn stars, born together in a cloud of gas and dust. These stars passed close to one another. Their gravitational fields interacted. It is possible, even likely, that during this chaotic period, the gravity of our young sun reached out and pulled in a wandering planet that had been ejected from another star system, a rogue planet, an exile from another world. If this is true, then Planet 9 is not native to our solar system. It is a stranger, a guest, a traveler from a distant, alien sun, captured by our gravity and held in place for billions of years. And the third theory is perhaps the most haunting of all. What if Planet 9 is not actually a planet? What if it is something far stranger? In 2019, two physicists made an unusual proposal. Jakob Schultz of Durham University and James Unwin of the University of Illinois suggested that the gravitational evidence for Planet 9 might not be a planet at all. Their idea: Planet 9 might be a primordial black hole. A black hole hiding in our own solar system. It sounds like science fiction, but the math is real. Primordial black holes are hypothetical objects. They are thought to have formed in the very first moments after the Big Bang, when the universe was still incredibly hot and dense. Tiny pockets of matter, compressed by extreme pressure, collapsed into black holes far smaller than those formed by dying stars. A primordial black hole, the mass of Planet 9, about 5 to 10 Earth masses, would be incredibly tiny, smaller than a grapefruit, just a few centimeters across. It would be invisible, almost impossible to detect. It would not reflect light. It would not emit light. Its gravitational influence would be the only sign that it exists. And that gravitational influence would behave exactly like Planet 9. Imagine, for a moment, a black hole the size of an apple, floating silently in the outer solar system, surrounded by the eternal darkness, bending space itself around its tiny, monstrous form. If this is the truth behind the gravitational anomalies, then we have something far stranger than a planet hiding in our solar system. We have a relic of the early universe, a whisper from the first second after the Big Bang, a piece of the cosmos older than every star in the sky. Astronomers are searching for ways to test this hypothesis. One approach is to look for tiny flashes of light produced when small comets or asteroids fall into the black hole. Another is to search for subtle gravitational lensing effects, the way a black hole bends light from distant stars. If we ever detect such a signature, it would be one of the greatest discoveries in the history of science. But there are still other theories. In 2024, a group of astronomers proposed that the gravitational anomalies might be caused not by a single object, but by a collection of distant, undiscovered objects, a swarm of small worlds, working together to shape the orbits of the distant trans-Neptunian objects. In this scenario, there is no single Planet 9, just a hidden population of smaller bodies, each one too small to detect individually, but together, exerting enough gravity to create the patterns we see. Other researchers have suggested that the anomalies might be statistical illusions, that with more data, the patterns might disappear. and some have proposed even stranger ideas. What if our laws of gravity are slightly wrong at extreme distances? This is the core idea behind modified Newtonian dynamics, or MOND, a theory that suggests gravity behaves differently when accelerations become very small. If MOND is correct, then we may not need a hidden planet to explain the strange orbits of distant objects. Each of these theories carries profound implications. If Planet 9 is real, we have a new world to explore, a frown-seen giant on the edge of our solar system. If Planet 9 is a primordial black hole, we have a window into the earliest moments of the universe. If Planet 9 is a swarm of smaller objects, we have a new understanding of how the outer solar system is structured. If Planet 9 does not exist at all, then our understanding of gravity itself may need to change. In every scenario, we are on the edge of a discovery that will reshape what we know. And there is one more theory, rarely spoken of in mainstream science. What if Planet 9 is something we have not yet imagined? The universe, after all, as a way of surprising us, every time we believe we understand its rules, it reveals something new, something stranger, something more beautiful than we could have predicted. Perhaps the truth about Planet 9 is something none of our current theories can capture. Perhaps the answer awaits us, patiently, in the darkness beyond Neptune, waiting for us to find it. Searching for a planet at the edge of the solar system is unlike any other astronomical search. The challenges are immense. Planet 9, if it exists, would be incredibly faint, reflecting a tiny amount of sunlight from an almost unimaginable distance. It would appear as a single dim point in a sky filled with billions of stars and galaxies. To find it, astronomers need three things: time, patience, and the most powerful instruments humanity has ever built. For years, the search was conducted using existing telescopes: the Subaru telescope in Hawaii, the Dark Energy Survey in Chile, the Pan-STARRS Observatory. These telescopes scan vast regions of the sky, looking for slow-moving objects, comparing images taken weeks or months apart, searching for anything that had shifted position. Hundreds of new trans-Neptunian objects were discovered, but Planet 9 itself remained elusive. The problem is the sheer size of the search area. Planet 9 could be anywhere along its predicted orbit. The orbit itself spans hundreds of astronomical units. The planet moves so slowly that even over years of observation, its position barely changes. It is like searching for a single dark grain of sand on an infinite black beach in the middle of the night. Difficult, almost impossible, but not entirely. In 2025, the Rubin Observatory began full operations. This telescope is named after the American astronomer Vera Rubin, who in the 1970s provided the first strong evidence for dark matter. The Rubin Observatory is unlike any telescope before it. Its main mission is called the Legacy Survey of Space and Time. Over 10 years, it will photograph the entire visible southern sky every 3 to 4 nights. It will create the most detailed time-lapse of the universe ever recorded. Its camera has a resolution of 3 billion pixels. It captures more sky in a single image than any other telescope in history, and it is specifically designed to detect faint, slow-moving objects. In other words, it is the perfect tool to find Planet 9. If the planet is real, and if it lies within the predicted area of the sky, astronomers expect the Rubin Observatory to find it within the first few years of operation. But there are other efforts as well. The James Webb Space Telescope, launched in 2021, has been used to study many of the strange distant objects whose orbits suggest the presence of Planet 9. It cannot easily survey the entire sky, but it can examine specific regions in extraordinary detail. The Nancy Grace Roman Space Telescope, scheduled to launch in 2027, will provide another powerful tool. With a wide field of view and infrared capabilities, it could potentially detect the faint heat signature of Planet 9. There are also citizen science projects. Through programs like Backyard Worlds, ordinary people have helped scan images of the sky for signs of distant, undiscovered objects. Several brown dwarfs and unusual objects have been found this way, and someday, Perhaps the discovery of Planet 9 itself will come from a curious mind looking at the right image at the right moment. In late 2024 and into 2025, rumors began to circulate. Whispers among astronomers, hints in conference presentations, carefully worded papers suggesting that, possibly, the data was beginning to converge. Some researchers claimed to have identified a candidate object, a faint signature in deep sky surveys, that matched the predicted properties of Planet 9. Others remained skeptical, urging patience. The truth is, we may already be on the verge of discovery, or we may have years still to wait. Either way, the search is one of the most exciting in modern astronomy. Imagine the moment of discovery. A faint point of light, moving slowly against the stars, confirmed in image after image. The data analyzed, the orbit calculated, the evidence undeniable. And then, the announcement. For the first time in nearly 2 centuries, humanity has discovered a new planet in our solar system. The headlines will spread across the world. Children will draw it in their school books. Astronomers will weep at the sight of a discovery they have spent their lives pursuing. We will name it, we will study it, we will dream of one day sending a probe to visit it, though such a journey would take decades, perhaps centuries. But more than anything, we will know. We will know that we are not alone in our own solar system, that there is another world out there, another companion to our Sunday, a Francine giant, revealed at last. And yet, even after the discovery, mysteries will remain. How did Planet 9 get there? What does its surface look like? Are there moons, an atmosphere, hidden oceans beneath Francine ice? Could life strange, alien, unimaginable exist there in some form? Each answer will reveal 100 new questions. This is the nature of science. This is the nature of the universe. It does not end. It only deepens. Let us, for a final moment, imagine that the search succeeds. Imagine that one quiet evening, in the mountains of Chile, the Vera Rubin Observatory captures an image, a faint, slow-moving point of light, where there should have been only darkness. Imagine the astronomer who first sees it, sitting alone at her console, staring at the data, realizing, slowly, that she is looking at something no human eye has ever seen. A 9th planet, the search of a lifetime, the dream of a generation, confirmed, in a single, quiet moment. What would Planet 9 look like? We do not know for certain, but we can imagine. A world larger than Earth, wrapped in a thick, cold atmosphere, perhaps blue-gray, like Neptune, perhaps banded with subtle clouds of Francine methane and ammonia. Its surface, if it has one, would be hidden beneath layers of dense gas. Or perhaps Planet 9 is something else entirely, a super-Earth, rocky, Francine solid, its surface a vast, silent landscape of ice and stone, sculpted by ages of cold and stillness. There may be storms, oceans of liquid nitrogen, mountains of Francine water rising into the dark sky. There may even be moons, small, captured worlds, orbiting their giant parent, each one a Francine mystery of its own. But more than anything, Planet 9 would be silent. Silent in a way that nothing on Earth can ever be. No wind would whisper, no water would flow, no life would stir, only the slow, eternal turning of the planet beneath the distant stars. The sun, from the surface of Planet 9, would be just another point of light, indistinguishable from the other stars in the sky, so far away that it would not bring warmth, not bring color, not bring hope, only a faint glow, a reminder of where the planet came from, a reminder that, somewhere out there, in the unimaginable distance, there is a star that calls this Francine world its own. And what would the discovery of Planet 9 mean for us? For humanity? It would be more than a scientific discovery. It would be a philosophical one. For 4,000 years, humans have looked at the night sky and tried to understand our place in it. We have named the stars, mapped the planets, imagined gods walking among them, sent our ideas, our dreams, and finally our machines, into the void. And every time we believed we understood the cosmos surprised us. We thought Earth was the center of the universe. We were wrong. We thought the solar system had only 6 planets. We were wrong. We thought Pluto was the last. We were wrong. We thought the universe was static. We were wrong. We thought we were alone. We may yet be wrong. The discovery of Planet 9, whether it is a planet, a black hole, or something stranger still, will be another reminder of the same eternal truth. We do not know everything. We may never know everything, but we keep looking. And that is the beauty of it all. The universe is vast. The universe is mysterious. The universe is filled with hidden things, waiting patiently in the dark for us to find them. Some of these mysteries are far away, galaxies so distant that their light takes billions of years to reach us, stars exploding in unimaginable violence, black holes consuming whole worlds at the centers of galaxies. But some mysteries are close to home. Some are right here, in our own solar system, hiding just beyond the orbit of Neptune, waiting for the right telescope, the right night, the right curious mind to find them. And that is what makes astronomy so beautiful. The universe is not finished revealing itself. There is always more. So tonight, as you drift gently into sleep, let yourself imagine the silence of the outer solar system. Imagine the slow, ancient turning of a hidden world, wrapped in eternal darkness, surrounded by the quiet brilliance of unfamiliar stars. Imagine the long, patient orbit it has traced for billions of years around our distant Sunday, carrying its frowning secrets through the void, waiting. Imagine the moment, perhaps soon, when our telescopes finally catch its light, when humanity sees, for the first time, a new member of our cosmic family. And imagine yourself, part of this great story, a tiny, conscious being on a small blue planet, looking out into the night, wondering, dreaming, searching. You are part of the universe, discovering itself. The mystery of Planet 9 is not yet solved, but the search continues. In observatories across the world, in the calculations of patient mathematicians, in the curiosity of dreamers like you. Somewhere, beyond Neptune, a hidden giant is waiting. And one day, we will find it. Until then, rest well, breathe slowly, let your mind drift gently into the deep, peaceful silence of the cosmos. The universe is vast. The universe is patient. The universe is full of beauty and mystery. And you are exactly where you need to be. Good night.